Alright, let's practice once again our properties for congruence. Alright, still our only possibilities for proving triangles are congruent to this point are SSS and SAS to this point in our lesson. Okay, so that's our only options. Let's go through and see if we can use either of those. Okay, so let's start with A. Given that segment SM is congruent to segment ML. Let's mark that. So the line going from S to M is congruent to the line going from M to L. And that segment SP, the line going from S to P, is congruent to LP, the line going from L to P. Okay. Can we prove that those two are congruent? And if we can, by which property? Well, let's take a look. We have so far, I should have put 2 marks there. So far, 2 sides of this triangle are congruent to 2 sides of this triangle. And then we have an angle here. Is there anything else we can mark based on what we know about geometry? Well, notice PM is shared between the 2 triangles, so it should be congruent to itself. So now what do we have? Well, we have 3 sides of this triangle on the left, congruent to 3 sides of the triangle on the right. So by SSS, the triangles would be congruent. Also, actually we have 2 things working for us this time. Okay, so I have 2 sides of this triangle and a congruent angle between them, and 2 sides of this triangle and a congruent angle between them. So actually for these 2 triangles, SSS and SAS would both work to prove they're congruent. Here's our next example. We have 2 sides marked congruent to 2 sides marked congruent. We don't have a third side, so SSS is not a possibility here. SAS will work as long as we have the angle between our congruent sides marked as congruent, and we do. So here is our side and our side. This is the included angle between them to give us SAS. And notice it is marked as congruent, so we have SAS, side, angle, side. So this pair of triangles is congruent by SAS. Here's our next figure. What do we have in this figure? We have 3 sides of this triangle congruent to 3 sides of this triangle. Well, right there we have SSS. None of the angles were marked at all, so we can't even really try side, angle, side, because we have no angle knowledge. All right, here's our final example. I want you to notice that it's very much like our first one. The only thing that's different is our given information. So here let's mark the given information. It says segment PM, so the line going from P to M, bisects the angle SPL. What does that mean? So this line PM bisects the angle SPL. Well, it means that it cuts it into 2 equal angles. Okay, so this angle here would be congruent to this angle here. Okay, carry on. And segment SP, the segment from S to P, is congruent to segment LP, the segment from L to P. Can I conclude they're congruent? Well, notice this time I don't have the third side marked as congruent, and they didn't give me information that would lead me to believe that. I do have, however, have one more thing I can mark on this figure, and it's that PM is congruent to itself because it's shared between both triangles. And notice now what I have a side, and the angle between them in this triangle congruent to a side, and the angle between them in this triangle. So by side, angle, side, these 2 triangles are congruent. Notice it was exactly the same figure, but based on our given information, the way we proved them congruent changed. This one was able to be proved congruent by either, and this one was only able to be proved by SAS.